Hello and good day to all my students. So this video lecture session will cover week 7 coverage, which is the time value of money. These are the topics outlined that we will cover for this session. We're going to start off first with the introduction of the time value of money, followed by the present value and the future value. And then we're going to discuss on the annuities, followed by the present value of mixed stream of cash flows. And then we're going to go to the compounding interest non-annually, loan amortization, and we're going to end the lecture session with some tutorial questions taken from the past year's questions. So what is time value of money? So time value of money dictates that the money that you receive today is worth more than the money that you're going to receive in the future. So it means that you will need more money to buy the same item that you purchase today if you purchase the item in the future. Okay, meaning that the purchasing power of your money is decreasing over the years. So why is it happen? Because the reduction value in money is due to the inflation, where the purchasing power of money is decreasing as years goes by. Okay, the concept of time value of money is based on the compounding interest concept. So what is compounding interest concept? This is where interest is calculated based on the principal plus the previous interest that you have compounded. Okay, meaning that let's say that this year you have interest, you have deposited 1,000 ringgit of money, and the investment pays you 10% of dividend. So for the first year, you're going to receive 100 ringgit based on the 1,000 money that you have deposited. So for next year, the interest that you're going to receive will include the money that you have deposited, which is the 1,000, plus the interest that you have received for last year's, which is 100,000. Therefore, the interest that you're going to receive on the second year is 1,000 plus interest last year, 100 ringgit, and times with the 10% interest income. So for the second year, you're going to receive 110 ringgit. Okay, therefore, under the compounding interest concept, the interest that you receive will compounded or will accumulated based on the interest that you have received. Another concept of interest is simple interest, where interest is only calculated based on the principal. So under the simple interest concept, the interest will be constant, meaning that year 1, year 2, year 3, year 4, your interest received is going to be 100 ringgit, second year 100 ringgit, third year 100 ringgit, because the interest is calculated based on the principal only, and the principal usually doesn't change. So there are two types of time value of money, which are present value and future value. So present value means we want to know the today's value of the money that we're going to receive in the future, meaning that I know the value of the money today, but I would like to know what is the value of that money in the future. Okay, whereas future value means we want to know what is the value of a series of money or a single instrument of money in certain point of the future, meaning that I know I'm going to receive, let's say, 10,000 in 10 years. So what is the value of that 10,000 in the 10 years time today? What is the value of the 10,000 to today? That is what we call as a future value. Alright, so here is some example on how we can calculate the future and the present value based on requirement of the questions. So the clue that you can use in the question, the clue that you can use in the question should dictate to you which formula you should use, meaning that should you use future value formula or should you use present value formula. So this is the formula for future value, where future value equals to present value times 1 plus interest rate or discount rate, power to the n. The n refers to how many times we want to accrue or we want to compound the money. 1 year, 2 year. So it doesn't necessarily have to be in yearly format. It can also be in terms of, let's say, 1 year you compound 2 times, so the n refers to 2. How many times the money is to be compounded. Okay, so Azrul has decided to place 400 ringgit, which he receives as a birthday gift, in a saving account paying 4% interest. So the question asks how much will, see the keyword will here. So the word will indicates future. So the question is asking for future value. So if the question is asking for future value, so please use the formula future value. So present value here would be the 500 ringgit because the 500 ringgit is something that he has already received. So it becomes present value. So you put in 1 plus the interest rate is 4%, 0.04, power to 6 times 6 compounding times. Okay, so you should get 632.50 cents. Okay. For this question, what would be the present value of 1,000 ringgit to be received 8 years from today if the discount rate is 5%? So the question is asking for present value. So please use the present value formula. It's quite similar to the future value formula, except the n here is power to negative end. Okay. So you put in the future value, which is the 1,000 ringgit. How do we know this is a future value? Because it says here to be received in 8 years. So put the 1,000, put the interest rate and the compounding for 8 years. So the 1,000 ringgit's value today would be 677 ringgit. Meaning that, let's say that you want to buy, a handphone worth 677 ringgit. Okay, it's not very good example because handphone is depreciating. Okay, let's say you want to buy gold. Okay, let's say the value of gold today, if you want to buy like 10 gram of gold, it's quite a lot. 3 grams of gold, it costs you today 677 ringgit. But if you wait for 8 years, the same amount, 3 grams of gold, in 8 years' time will be valued at 1,000 ringgit. So it's the same amount of item, except the value of the money is decreasing. Therefore, you need more money to buy the same amount of item. That's what it meant by time value of money. Okay. So there's also another question here that Faizal intends to buy a new car, the Myvi, for 57,650 ringgit, but only has 20,000 in cash. So how many years will it take for the 20,000 to grow to 50,650 if it's invested at 10% interest compounded annually? So the question now is asking for N. They've given you the PV, the present value, and also the FB and the I. Okay, so you can put in the future value and the present value. And when you divide these two figures, you should get 2.8825. And if you refer to the table, you're going to find out at 10%, the value of 2.8825 is 11 years. So what is this table that I'm talking about? Let's go to the next slide. So how do we read present and future value tables? So aside from using the formula that I've shown you previously, we can also use the table to find the future or the present value. For example, Azrul had decided to place 500 ringgit. This is the previous example that I've shown to you. And we have calculated the amount using this formula. But we can also use, we can also find this figure by using the table. You don't need to calculate. You can refer them to the table. This is the example of the present value table. So how do we differentiate between these two tables? Look at the title in the table. So here is the present value and here is the future value table. So if you are using future value formula, please use future value table. If you use present value formula, please use present value table. So in this case, the I is 4% and the N is 6. So you look at 4 and you correspond in the figure with 6, you should get 1.2653. You put in here times with the 500 ringgit, you should get the same answer as if you use the formula. Okay, so next we're going to see annuities. What is annuities? So in the previous example that I've shown you, the money that we want to find the value in the future or in the present is just a single installment, meaning that Azul received 500 ringgit in the future in 6 years time. So Azul received the money today, only once. The 600 ringgit happens only once. Okay, but annuity is where the money is deposited in the periodic manner. For example, every 3 months, every 6 months, or every year. Okay, for example, Azrul has deposited 500 ringgit annually. So there is a word such as annually, yearly, per annum, which indicates that the money is deposited more than once. So unlike the previous example where the money is deposited only once, in the annuity question, you're going to see words such as annually, every year, yearly. Those words can be served as clues for you whether the question is asking you to use future or present value or the annuity ones. So there are two types of annuity. One is ordinary annuity, the other one is annuity due. Okay, so you need to be careful in the question, because if you have mistakenly assumed that this question is using annuity due and this question is using ordinary annuity, your answer will be wrong, because ordinary annuity will have different effect as compared to annuity due. Okay, why is it so? Because ordinary annuity is where the money is deposited at the end of each year. So the keyword here is at the end of each year. Okay, but for annuity due, the money is assumed to be deposited at the beginning of each year. So depositing the money at the end or at the beginning of each year will give you different impact, because it will affect the number of compounding that you have to calculate. Right, so this is important because it will decide whether you are entitled to receive the interest for that particular year. So how does depositing the money at the end and at the beginning of each year differs in terms of calculations? So if you look, I have given you two timeline here, and the money is deposited in the yearly manner, 1,000, 1,000, 1,000 for 3 years. For the money to be considered as annuity, there must be even, sama, even, and there must be consecutive, year 1, year 2, year 3. If it's not even or if it's not consecutive, then the cash flows cannot be considered as annuity. Alright. So on this side of the slide, this is what we call as present value, and on this side of the slide is what we call as future value. So the red table here is where, see here at the beginning of each year, right? So this is annuity due. Okay, see here at the end of each year, the green table, this is ordinary annuity. So if I want to calculate the present value of these cash flows, if it's deposited at the end of each year, okay, year 1, year 2, year 3 at the end. So what is the present value of these three cash flows today? So if you deposited the money at the end of each year, and you want to bring the money to the at the end of this current year, so you can see that here it completes one compounding effect. For the second year, you have to bring forward to year 1, one compounding effect, and then to year 0, two compounding effect. So here we have to compound 2 times. For the third year, 1000, we have to bring forward the third year to second year to the first year, and then first year to the year 0. So you can see 3 compounding effect. So the present value of this cash flow using the formula present value is 2486.85. Okay, but if you are calculating the present value of these cash flows using the annuity due, which means you deposit the money at the beginning of each year. See here, 1st January, 1st January, and 1st January. So you can see that on the first year, you deposit the money for the first year, and you want to know the value at the end of year 0. So this is just 1 day. The time spent here is only for 1 day, so it is not entitled to have any compounding effect. So we take it as it is, which is 1000. So for the second year, you only have to compound 1 time. See here, it's negative 0, negative 1, because here is more or less the same, kan? 31st December and the 1st January. So this is only for 1 year compounding effect. For the third year cash flow, 2 compounding effect. So you can see here under the annuity due, the present value is much higher compared to ordinary annuity. So for present value, okay, annuity due reduce 1 year compounding effect. Annuity due reduce 1 year of compounding effect. Okay, so for future value, we deposited the money at the end of each year, and we would like to know what is the value at the end of year 3. We would like to know the value of the 1000, 1000, 1000 at the end of year 3. Under ordinary annuity, we're only going to compound 2 times because the third year 1000 is already at the end of year 3. So it's, the money isn't entitled to receive any interest. So you're going to take it as it is. But for the second year money, you're entitled to receive 1 year interest. For the first year, 2 years interest. Okay. However, if you deposit the money at the beginning of each year, you're going to see on the third year, we are entitled to receive 10% interest because it's already for 1 year. See, the money is deposited at the 1st January, and we would like to know the value at the 31st December. So it's already 1 year. So please compound it by 1 year. The same goes for the second year 1000. Here is 1000. 1 year. Here is another year. So 2 years, 3 years. So here you can see the value under the annuity due is much higher than the ordinary annuity because we are adding 1 year compounding effect. So let's see some of the questions. This is the question example for the ordinary annuity. Okay, Siti Asha wishes to deposit 1000 annually for 5 years into a saving account that pays 6% interest. How much money will she have at the end of 5th year? Okay, so the question is silence here. We don't know whether Siti Asha deposit the money at the end or at the beginning of the year, because the question is silence. But please assume that this is ordinary annuity. If the question is silence, the question is asking for ordinary annuity. Okay, so therefore we use the formula here, future value annuity. The PMT here is referring to the payment that Siti Asha made every year. And the PVIF is 6% and 5 years. So here you have to refer to the present value table that has the word annuity, future value annuity. So you look at the table at the 6% corresponding it with the 5, and you should get 5.6371. So the money, the value of the 1,000 that you deposited every year for 5 years is 5637410. But for annuity due, the question must mention either the word annuity due, or the question is saying the money is deposited at the end of each year. So if the question is mentioning when the money is deposited, it is at the beginning of the year, therefore please use the annuity dues formula. So annuity due formula is quite similar to the ordinary annuity, except we have to add one more compounding effect if you are using the future value, and you have to lose one compounding effect or reduce one compounding effect if you are using the present value. Okay, I say here is reduce, here is adding, but the formula remains the same. Here you have to times 1 plus I. So you get 9636.62. Next, we're going to cover the present value of mixed stream of cash flow. So previously I've said that for the annuity to be considered as annuity, the cash flow must be evened, 1,000, 1,000, 1,000, and the cash flow must be in consecutive manner, 1,000 year 1, 1,000 year 2, 1,000 year 3. So sometimes the question will give you cash flows that are not even or they are not consecutive. So we call this as a mixed stream of cash flow. For example, for the cash flow number 1 here, year 1 we deposit 1,000, year 2 we deposit 1,000, year 3 we deposit 2,000, year 4 we deposit 2,000, year 5 we deposit 2,000. So we can see here the cash flows are consecutive, but they are not even, tak sama ni, 1,000, 1,000, 2,000. So we cannot use annuity for the 5 years cash flow. Instead, what we can do is we can separate them into two, because you can see here is consecutive and even. Here is also consecutive and even. So we can separate them into year 1 to year 2, year 3 to year 5, put the figure 1,000, 1,000. Okay, so we can annuity this 10% 2 years. 1, 2. So 2. So 1.7355 times with 1,000, you get 1,735.50 cents. Okay. For the 3, 4, and 5th year, 3rd, 4th, and 5th years, I want you to look at the table here. Okay. 5 and 6 and 2. Okay, so when you want to find the annuity to be used for the cash flow that happens in the middle of the timeline here. Okay, so you must look at the end of figure here, 5 minus 2. So you find first annuity 5. Annuity 5 is 3.7908. Find this annuity 2, 10%, which is 1.7355, minus first these two figures. Then you times with 2,000. You should get 4110.60. So the present value of this cash flow is 5846.10. Okay, so for the cash flow number 2, we only start depositing at year 3, year 4, and year 5. Year 1 and year 2, there is no money to be installed. Okay, but when you do the tabulated method, do not forget to still put in the year 1 to year 2, because even if we haven't deposited any money, the compounding effect still counts. The compounding effect still counts. So you start off with year 1 to year 2, year 3 to year 4 because 2000, and year 5 is stands as its own because it doesn't have any repetitive cash flow. Okay, so as usual, I would like you to look at the end figure here. Okay, the end figure here. Oops, sorry. And the end figures here. Oh, sorry. Okay, so 2, 4, 5. So for the first year, leave it as it is because there is no cash flow to be calculated. But for the 3 and 4th year, so annuity 4 minus annuity 2. Minus first, then you times with 2000, you get 2868.80. For the 5th year here, it is not an annuity. So you can use simple present value, which you get 0.6209. But if you still want to use the annuity 5 minus annuity 4, you should still get 0.6209. So you times with 1000, you get 620.90. So the present value here is 3489.70. If you look at the third cash flow, the cash flows are not even and not consecutive. So we cannot use annuity at all here. So here I use simple present value. Look at the table, put in the figures, and you times with the cash flows accordingly. You should get the present value here. Next is we want to learn on how to compound to calculate the present or the future value money if the interests are not compounded annually. So far the example that I've shown to you before, the interests are all assumed to be compounded annually, meaning that 1 year lapse, you should get your interest or you should pay your interest. However, there are some loan or some investment that compound interest not in the yearly basis. For example, credit card. Credit card compounded your interest on the monthly basis. Okay, if that's happened, then you need to modify the formula a bit, because the formula here is referring to the yearly basis, and it's okay because the interest is also in the yearly basis. But if the interest here is in yearly basis, but the compounding is on a semi-annually basis, then we need to modify the formula a bit. Okay, so I here is supposed to be on the yearly basis. So if 6% is yearly basis, so for every 6 months, then the interest will be only 3%. Okay, so you divide by M. What is M? M is how many you compound in 1 year. So if the interest is compounded semi-annually, then in 1 year the interest is compounded 2 times. 2 times. If the interest is compounded monthly, then the M here should be 12 times. 12 times. If the interest is compounded quarterly, then M here should be 4 times. 4 times. So you divide by 2. Okay. And the interest here, if for 2 years, then you have compounded 4 times. 1 year, 2 times, right? So 2 years, 4 times. So the future value is 1125.51 ringgit. Next, we're going to look at the loan amortization. So loan amortization is a schedule. Yeah? It's a schedule that shows to you how much you pay to the bank, interest base, and principal base. For example, what will be the equal annual end of the year payment necessary to amortize fully 5,000, 5% loan over 5 years? So we have a loan of 5,000 and we would like to finish off the loan after 5 years. So the question is asking how much you must pay every year, so that after 5 years the loan value becomes 0. So in order for you to find the PMT, the payment that you made every year, you need to use the present value or future value annuity. But we cannot use future value annuity, cannot use future value because the future value for the loan is 0. So we cannot divide by 0. That's why here I use present value annuity, because currently we have the value of the loan which is 5,000. Therefore I can divide these two figures. The PMT that I have to make to the bank every year is 1154.84. So here within the payment that I made to the bank, it consists of the interest component and also the principal components. So the interest component is calculated based on the interest rate times with the opening balance of the loan that you still have. So if the 250 is the interest, therefore the remaining here would be the payment for the principal. Okay, so this is the table. I have the opening balance and the payment that I made every year, and I know the interest here. How do I know? 5% times with the 5,250. So how do I get the principal of 904.87? Okay, the PMT minus the interest, I get the principal amount. So to find the closing balance, the principal minus the principal. So the closing balance is 4095.13. You bring forward to the next year. Therefore, you calculate the interest based on the new balance of the loan. So 5% times with the opening balance, 4095.13. You get 204.76. And the remaining would be the principal. So principal minus principal, you get 3145.02. So you do it until the end of year 5. You should get more or less 0. Okay, if you cannot get pure 0 answer, then it's just a mathematical error derived from the decimal point when you round out the figure. Excuse me. Okay, decimal comes from the round out figure. So you can hear here, total payment to bank is 1154.84 times with the 5 years. So we have paid to bank a total of 5,774 ringgit 20 cents for the loan worth only 5,000. So the extra amount that we pay, the 774.20, represent the total interest that bank charge upon you, which we have spread over 5 years of payment. So the total interest here, you can see, is similar to those that we have calculated. So let's do some of the tutorial questions that I have taken from the past year question. So Encik Ali is planning to retire by the end of this year. The company is offering Encik Ali 2 options for his retirement payment scheme. Encik Ali can either receive a lump sum of 200,000 now or 25,000 per annum for the next 10 years. The question is asking, discuss the best option of retirement payment scheme that Encik Ali should choose if the discount rate is 8% per annum. So we have 2 options here. This is Encik Ali. Option 1 says that Encik Ali can receive a lump sum of 200,000 now. And that's it. That's the retirement fund that he has. Or he can spread the retirement fund over 10 years. Okay, over 10 years. So on the surface that it looks like as if 235,000 for 10 years is much higher than the 200,000 to be received now. But we cannot make that kind of conclusion because here is at year 0 and here is at year 1, year 2, year 3, year 4, year 5 until year 10. So how can we compare cash flow in year 0 with cash flow in year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? It cannot. To make it comparable, we need to bring all the cash flow to the same point of year so that the comparison done is more accurate and more fair. So what I do now here, I would like to present value all the cash flows and to find the value of those cash flow in year 0 to be compared with 200,000 that received in year 0. So please use present value annuity because the cash flows are even and consecutive for 10 years. Okay, so put in the PMT 25,000, the annuity factor, look at the table, and the present value for those cash flow is only 167 ringgit 752.50 cent, which is much lower than the option 1. Therefore, choose option 1 due to higher present value. Part B says that if the company chooses to extend the retirement payment scheme to 20 years instead of 10 years, now it becomes 20 years. So calculate the annuity for the option 2. Now we change to 20 years. And we see that the present value here is 245,552.50, which is higher than 200,000. Therefore, we choose option number 2. Okay, for number 2, Darwish purchased a car of 120,000 and has paid 20,000 as down payment. He agrees to pay the balance over 5 years in a 5 equal end of the year payment that includes principal plus 5% compound interest on the unpaid balance. So they ask you to calculate the amount of equal annual payment of the loan. Okay, how much we are borrowing? We are only borrowing 100,000 because we paid 20,000 down payment. So we borrow for 100,000 and we use the present value annuity because future value is 0. Okay, we cannot use future value annuity. So put in the present value loaned 100,000, annuity 5% 5 years 4.3295, divide the two figure up, you should get 23,097. So when they ask you to prepare the loan amortization schedule, this is how we prepare it. Start off with the opening balance, put in the answer that you have calculated previously. Calculate the interest 5% times the opening balance. So the balance here would be 18,097 ringgit, and the closing balance here is principal minus principal 81,902. So I have done it until year 5 and the final figure here is 2. So it's not exactly 0 because I have been rounding out since year 1. So there is an error, mathematical error of 2 here. But it's okay. It's okay. So the third tutorial question here, Tasni wants to purchase a car which costs 50,000 in 2 years' time. She wants to be able to pay down payment of 5,000. Okay, so here is Tasnim. She wants to be able to pay down payment of 5,000. So the question is asking how much she needs to deposit now. Just a single figure. The question doesn't say how much she needs to deposit annually. The question only says how much she needs to deposit now. So the question is using the simple present value formula. So the future here is 5,000. The 10% here and the 2 years 1, 2, negative 2. So the present value she must deposit for 132.23 today so that the money can accumulate to 5,000 after 2 years. And then part B says calculate the annual amount she needs to pay for the higher purchase loan so that after 5 years the loan becomes 0. Okay, so the question is asking for PMT. How much she must pay every year? How much she borrowing? She's borrowed for 45,000 because she already have accumulated 5,000 and she doesn't need to borrow the whole 50,000. She can only borrow 45,000. So put here present value here 45,000. And the annuity factor 7 years and 4%. And every year Tasni must pay 7497.38. That's the amount that she has to pay every year. So that's the end of time value of money lecture session. So for your to enhance your understanding and comprehension, please do pass this question uh, on this particular topic, and I will soon upload the answer for you to check. And if you have any question, as usual, please ask me. So thank you for your time and your patience and your attention. I will see you on the next video lecture session.